In this lesson, we're going to look at creating a general factoring strategy. So basically, we're going to look at where do we start when we're asked to factor a polynomial? What do we do? Well, you can think of a systematic process of deciding which techniques to use depending on what criteria you have in your question. The first thing to do, always, is to take your greatest common factor out first, if possible. Once you have done so, you can look at what you have left in your bracket. Do you have 2 terms, 3 terms, or 4 terms? If you have 2 terms, you basically have 2 options. There's the 2 special factoring formulas, the difference of squares, so maybe you have 2 perfect squares with a minus in between. You can follow that formula. And you have a sum or difference of cubes, which then you may follow this formula. Next, if you have 3 terms, you have 3 options. Remember that the general form is the decomposition method, so that can always be applied. However, the first 2 options I've listed here are somewhat shortcuts of the decomposition method. So maybe you notice that the first and last terms are perfect squares, and you can just check if the middle term works out to be a perfect square trinomial. If you don't see perfect squares, maybe you don't have a leading coefficient and it's only a 1. In that case, you can directly factor without having to split the middle term. And the 2 numbers that are in your second position of your binomials would have a product of your last term, C, and a sum of your middle term, B. However, if you do in fact have a leading coefficient and it's not a perfect square trinomial, you can always use the decomposition method, the ultimate factoring method, because it works on essentially any trinomial of the form where the leading term is of degree 2. So in the decomposition form, recall that you can split the middle term, and you can do that by finding 2 numbers that add up to the middle term, they sum to B, and they have a product of the first times the last term. After which you can use the grouping technique. If you have 4 terms right off the bat, you can just go ahead and try the grouping technique, which was taking the first 2 terms and taking out the greatest common factor, and then making sure that same bracket is left when taking out a common factor out of the second 2. If none of these strategies work, and you're not able to break down your polynomial, then the polynomial is called prime. However, if you do at least one of these things, then you have already factored, even if it's just taking out the greatest common factor. If you do one of these factoring strategies and one of your components can still be factored further, do continue factoring until all the factors cannot be further factored, which means all factors need to be prime. Let's take a look at some examples where we can use the factoring strategy. Remember, we're always first trying to take out the greatest common factor if possible. In this example here, we have the greatest common factor of 5, so let's take that out, and no letters come out. So we've got 16x to the 4 minus y squared. Now we can take a look at the inside bracket and see if we can further factor. This is an example with 2 terms, so if you look back, 2 terms was either a difference of squares or a sum or difference of cubes. So we look at this and we can see that 16x to the 4 and y squared are squares. So it's a difference of squares. You can remember the formula, a squared minus b squared is multiplying a plus b times a minus b. So let's apply that here. So we're going to be left with a plus and minus term with the same first and the same last. So 4x squared and y, and 4x squared and y. If you're not sure, you can always multiply it all out and double check if it gives you back the original question. In the next example here, we can also try and find the greatest common factor first. Is there a greatest common factor? Well, I think there's an x squared that is common to all, and that's about it. So let's take out that x squared. We're left with y to the 4 minus 8y squared plus 16. Now, what we have here is a little bit different of a format. However, you can relate this to the variable actually being y squared itself, because the variable squared, y squared squared, is y to the 4. In order to look at our general factoring strategy, we can see we have 3 terms. So let's look and see what we have under 3 terms. Our first shortcut to look for would be whether it is a perfect square trinomial or not. So do we have perfect squares at the beginning and the end? Why, yes, we do. This here is a y squared squared, and this here is a 4 squared. So the only thing that remains is to check the middle term to see if it follows the format of twice the first times the last. Does it follow to be minus 2 times the first y squared times the last 4? Is this correct? Well, 2 times 4 gives us 8, y squared. Yes, it does. Therefore, we can use that formula and say that the first term minus the last term, all squared in a bracket, will yield the following when it is distributed out. Also, never forget your greatest common factor that you took out at the beginning. A note here is that you may not have noticed or seen these perfect squares. If you had forgotten to notice the perfect squares, you would have noticed that the coefficient was not 1. Actually, the leading coefficient was 1. So since the leading coefficient was 1, you could have also completed the second method, which was directly factoring. So since your variable was actually y squared, you could have said, okay, take out the x squared, we're left with this. Anything other than this will be longer, but here's an alternate route that you could have gone. You could have said, well, x squared. Now, since the leading coefficient is 1, I'm going to look for 2 brackets. They have to start with y squared, so that y squared times y squared gives me y to the 4. And 2 numbers that have a product of 16 and a sum of negative 8. Well, 2 numbers that multiply to 16 could be 1 and 16, 2 and 8, 4 and 4. Which numbers have a sum of negative 8? A sum of 8. So you could have negative 4 and negative 4, and you could also do it this way. If you forgot about this shortcut, you could still do decomposition, and I'll let you try that on your own. Would it work with decomposition? Could you, in fact, separate this middle term into the 2 numbers that result from multiplying to 1 times 16 and adding up to 8 using the decomposition method? Try it out. See if you can apply the decomposition method on this, or just the direct factoring on this, or the shortest way, which is actually just noticing the format. And in the shortest way, you could go straight from here to here if you did in fact notice it. This takes practice, so take your time with it. You can do the longer way. You can, if you really like, you can always stick to the decomposition if you find that easier. And it might also be nice to start with that and just complete it and notice that, okay, I have a system in case I can't find any other way of factoring it. Here's some more examples. So always start with taking out the greatest common factor. Let's try that. Do we have a greatest common factor? 8 can come out. XY can come out. So we're left with 8m cubed minus, and we are left with an n cubed there. So now inside we have two terms. So let's look back. Two terms, we had either a difference of squares or a sum or difference of cubes. Which one is it? Well, we have cubes, and it's a difference of cubes. So we should recall the formula, a cubed minus b cubed equals, and you can look back and check out that the formula will be a minus b and then a squared plus ab plus b squared. Let's just write that out. A minus b and a squared plus ab plus b squared. So what is our a and what is our b? GCF has to stay hanging out the whole way through. Here we've got 2m cubed and n cubed. So our a is kind of like our 2m and our b is our n. So let's set it up, write it all out. And fill in our a's and our b's. Now we can simplify that. GCF, don't forget it. 2m minus n times 2m all squared, giving you 4m squared plus 2mn plus n squared. Now, some of you may wonder, hey, this looks familiar. Could we maybe factor this out? Why, yes, you could. Potentially, you could take the middle term and split it up. Let's see. What's our product? Product would be first times the last, which is 4, and the sum would be 2. So we need two numbers that multiply to 4 and add up to 2. So 1 times 4, 2 times 2. Do either of those add up to 2? No, they don't. Therefore, this in fact is a prime factor, a prime polynomial, so it can't go any further. But it's always good to check, because sometimes it could be. So that's as far as we can go with that example. Let's take the next example over here. We've got 3 terms. Let's try and take out the greatest common factor first. So the greatest common factor, we've got 2. They're all divisible by 2. And a to the power of 4. So that leaves us with 3a squared minus 13a to the 1 minus 10 and no a. Great. Now we can continue and look for factoring the bracket. We've got 3 terms. So let's look back. For 3 terms, you can look for, is it a perfect square trinomial? Is it of the simpler factoring, direct factoring format with leading coefficient 1? Or does it have a leading coefficient that we need to do decomposition on? So let's look back here. There are no perfect squares, and there is a leading coefficient. So if you do have a number in front, you need to split up the middle term so that its sum is the middle term, negative 13, but its product will be coming from the first times the last, 3 times negative 10, which was negative 30. So let's see if we can find 2 numbers so that they multiply to negative 30 and have a difference, because the product is negative, of 13. 1 times 30, 2 times 15, 3 times 10, Let's keep going. 4 doesn't work. 5 times 6. And that's about it. Do any of these have a difference of 13? Why, yes, 2 and 15. So if we had negative 15 plus 2, that would give us negative 13, and they would multiply to negative 30. So remember, maybe draw an arrow to remind yourself you need to include the greatest common factor in the final result. But let's apply decomposition here. So the middle term is going to split up to become a 2 and a negative 15. We got 3a squared plus 2a minus 15a minus 10. And let's apply grouping. In the first two, we've got a common factor of a, leaving us with 3a plus 2. In the second two terms, we've got a common factor of negative 5, because we want both terms to be positive, leaving us with 3a plus 2. Great. We've got the common factor of 3a plus 2, and we have a minus 5 left. And we cannot forget our greatest common factor.